All right. So again, for OOP this year, this fall, in 2023, go ahead and watch these old videos. This will give you information on OOP and how to go through it much deeper. If you come out here to the link, make sure you read this material and practice a little bit with OOP and understand the difference between it. So with OOP, you're using objects as opposed to variable names that you guys are using today. So an object, and what we would like to use that is the example they'll give here is a dog, right? So that one's employee. Let's get to the dog example here. Okay. So we set up a dog, and to do that, we set up a class, and then we use the word dog. Notice dog needs to be capitalized. It's not like a function that should be lowercase. These should be capitalized when you do a class, all right? Under that, we have the init function. And so you're going to see this underscore init, and then it's going to take in two variables. So when we call dog to create an instance of a dog, we need to pass in the name and we need to pass in the age. And so this is going to set variables under this class of name and age so that we can access them. All right. Any functions associated with a dog, we would put it under this object. So say we have a fancy way of giving the dog's name, or we're calculating age of a dog or something like that. All of that gets put under this object. And again, this will make more sense when we talk about a player object for most of your guys' midterm projects. So here we can set variables that are specific to every instance of a dog that we create. So for example, species is going to be canine familiaris, all right? There may be other things that we would set up inside of there. For example, I'm just scrolling past the stuff we don't necessarily need to do. Here, for example, if we had a description of our dog, we could then call the description function, and it would return this string that would give us the description, which is their name is a X years old kind of thing, right? And we could do another one that says speak, in which case the name of this dog says, and then we tell it to say some sound, whatever it is, all right? The idea is that when you create a class, it will have its own functions. It will have its own variables that are all associated with that dog. So then all I have to do in my code is say dog dot description, and it will give me the string of whatever that description is. All right. As opposed to me having to formulate a print string and all that. I already have a dog. I just say dot description, and it gives me that. Most of you guys have already played with this. For example, the random module, right? Random inside its class has a function called randint, which then takes in the variables to create a random integer, right? You guys are creating your own module, so to speak, by creating your own class. Okay, clear as mud. I get it by all the look on your faces. So where would this apply in most of your guys' code that you've done within the midterm? If we come out here, and let's create a new file, and say you guys currently have a what's the word? Adventure game. You have some adventure game that goes through, and it goes through a bunch of stories, etc. But what most of you guys have is something like an inventory in here, right? And you have a list, and then as they're going through, you do something like inventory dot append, and you append the sword or something like that, right? Then at the end, you guys have this inventory, and at some point you guys may print that inventory. So you could have something like a function called print inventory. And at that point, it needs to have access to your inventory. I'm just going to assume it's like this. And we would have something like print, and we'll do an F string, and we would say item. And maybe we have a number in front of that or something like that. For now, we're just going to make it real simple. For item in inventory, print item. Okay. And some of you have a little more elaborate, or maybe it picks options, etc. So most of you in your adventure stories have some function like this that does an inventory, adds, and then prints it out. We want to do something like creating a player object. So what you would do is have something like class player, okay? And every player in your game is going to have some attribute. So say you have def init, and every time we create a player instance, we want to gather the player's name. So when they first start your game, maybe you have them gathering a name for whatever they are. We would say self.name equals get name. All right. And then we would have self. At this point, we don't have anything for the inventory. So let's move our inventory inside of our object. All right. And then we would move this function of printing the inventory inside of our object. Something like that. And then we need a function called get name so that it goes out and gets the name. So we would have def get name. All right. Now, when we're inside of classes, we always have to use this self, this concept of self. In other words, use this object in order to get access to the things below it. So when I say self.name, that's going to become a name inside this inventory. And I said I wasn't recording, but I am. Sorry. So it is recorded. I'll make sure it's posted. When we do this get name here, we would need to set that. So we would have something like while true, and then we would have a print. What is your name, Explorer? I don't know, making up whatever text adventure game you guys got. Something like that. And then inside here, we would have a input for this. So we could say name equals input, and we'll do a little fancy input. That. And then we obviously need to check to make sure that input's valid. So how do we check names? How do we check names? That would help fix that. There's a default for every time we want to check a name. Everybody should be using this way of doing it. Is title, right? So if name dot is title, then from is title, we would say print you entered, and then we could put in the name. Something like that. And then we want to store that. So we would say return name. And the reason we're using return here is we called it up here so that it would store the local variable name to this player. Okay. If they did not give us a is title, we could say something like print that is not valid input. Please try again. Okay. And that will keep them in the while loop until we actually return the name. We don't need a break here because we actually return the name in order to get out of this function. Now, the reason we do this is say somewhere in the middle of the project, you want to have them have the ability to change their name. Well, we don't have to set them up at the very beginning to run back through all of that. We just simply call player.getName anytime we want them to change their name. So probably not changing the name very often, but say they have a character type and you want them to be able to change their character type halfway through the game. You can call player.getCharacterType and it would allow them to change their settings as to what they are. All right. So by default, maybe this player character equals org or something. I don't know. I'm just making something up here. If you want them to have an option of picking different types, well, then you would have a function down here inside this class that has something relevant to this player. All right. Now in your code, you're going to have something like my player equals player. And what that does is initially come up here and call this player function and creates this player object. All right. From there, we can then go through and test it. So we could say my player dot name, and we could just put this inside of a print and it should print it out for us. So if we do my player dot name, we would get that out. And so if I run this simple little test here, let's see here, example class. Okay, we have a get name not defined, right? Well, we're getting a get name to here because we did not have self in this. So anything that happens inside of this class needs to have self run in front of it. All right, it's the easiest mistake. Here on this inventory, we need self in front of that as well. Forgot that piece. On this inventory here, this is self.inventory. We're saying of this player object, grab the inventory and put that out. If we had another one here, that would be something more like def print character self. Then on this one, we might have something like print this character is a, and then we would do something like self.character. That's going to print out whatever we have stored up here. And we need to make sure we have grammar. That's a lot of things I've seen so far. A lot of people are having misspellings, grammar, wrong punctuation. It's college, folks. Make sure you guys have that fixed in your midterms. Okay. I hate taking off points for spelling, grammar, and punctuation, but it is college. All right. So you have something like this, and instead of calling this player name, we could actually call the function myPlayer.print character. And it will actually print it out. So now if we run this again, all right, and we have, what is your name, Explorer? And I type in gibberish, it's not valid. If I type in something that is not, AKA has a uppercase character followed by lowercase character, it will take it. And then it comes back here and says, you entered name and you entered character. So what am I missing that I'm getting this output?
F string.
F strings, right? So I need to put an F in front of here and an F in front of here. And that gets us our proper F strings. We run this again. And I put in Jason. And now we say you entered in Jason and this character is an org, right? It pulled that information from us calling print character, which then comes up, calls this function, and it pulls from self.character. Any variable that we have assigned up here, it will actually print that out. But what's nice, if we did this in an interactive way, we need to append this sword. So right now, we can't really append this sword. What we would actually call is something like myPlayer dot, let's see here. You would have inventory. There we go. And for our inventory, we would append sword. Does everybody see how that changed? Because now we want to refer only to our player. And we could have multiple players. If I want another, say it's a player 1, player 2 game, I could just change this. Instead of saying my player, we could say something like player 1. And if I want a new instance of player 2, I do player 2 and create that object as well. Okay. And then here, if I wanted to print those characters, I just have player 1, and then I could do that again for player 2, etc., all the way down. So you can create multiple versions of that. Another way some of you guys may be doing it is, say you have enemies and you want to create multiple copies of an enemy. That's how you do it. You just create enemy 1 equals enemy. And enemy object has everything associated with an enemy. So maybe it has a special saying, maybe it has something that's stored for every single enemy. If you guys are playing with Pie game or something like that, and you create enemy classes, things like that, you got to store that information out. All right. So we have this. We're going to rename this player 1 just to keep up with the new way of doing it. And then say at any point in time in my code, I wanted to print the inventory. What would I type down here at the bottom? Player 1. Just like that. So if we run that, notice that inventory now is not a global variable. It's only relevant to this character. So if I create multiple characters, I now don't have to create inventory 1, inventory 2, inventory 3 for every single character. It automatically has that variable of inventory associated with itself. Does everybody kind of see how that works? It saves you code and it's relevant to that particular character. It'll automatically format that out. So if we look over here, it says inventory, not, oops, that's the wrong one. I need to full screen this. There we go. So what's my name? Jason, not a valid because I didn't capitalize. And now it's going to have this as an inventory of sort because we appended that. And if I append in a bunch of other things, AKA I'm in the middle of your loops and you guys are low and left or going right or something like that, then we would do player 1.inventory dot append, and maybe we are appending a key of some sort. And then you guys are doing checks somewhere in your actual code down here, right? So you can say if key, not hey, but key in player 1 dot inventory, then you allow them to go on to the next section. If it's not in there, well, then you have to make them go back and find the key. So maybe they got to go left or right or start over from the very, not from the very beginning, but start over from the outside of the cave. I'm using examples from students that have done stuff like that in the past. But this allows you to check to see if whether or not they have that thing in their inventory. If not, don't let them go on. A good example of that is key, right? You're having them go through multiple doors. If they haven't got the blue key for that door, then they can't go through. All right. Other ways that you would use an object-oriented programming, player is probably the number one. If you were doing something like tic-tac-toe, etc., player still works because now instead of an inventory, you probably have something like a scoring system. So you would have something like score equals 0, and then you have a function in order to add to that score based on what happens. So maybe they defeat an enemy or something like that, and they get plus 15 health. So instead of score, we would use something like health, and they start off with a health of 100. Every character starts with a player health of 100. At some point down here, you could have a function that says deduct health, and maybe it's a random number that we're deducting from their health based on whatever got hit. So how would we write a function that allows us to randomly deduct a number between 1 and 10 for their health? Does anybody know what that function would look like? So we got to start with defining it, right? And we would say lower health, for example. All right, what would we need to do to get started here? Import random at the top. Especially if you spell it correctly. There we go. Just a little space here. Down here, what would we do to create a random number to deduct it? Rand in, right? So we could use something like self.health minus equals, and then we could just create a random number to subtract from that. So we'd have something like random dot rand in, and we want to create a number between those two. So what do we put here? 1 and 11, right? Because it's up to but not including, and it will automatically subtract our health based on that lower health. The nice part is every time you call this function, it grabs a random number all the way through. So you don't set a random number once. Every time we call that function, it's going to deduct that health. So somewhere down here, you guys have determined that we want to, they got hit by an org and we want to deduct their player health. We just say player 1 dot lower health like that, and it automatically lowers their health. So if we want to test that, we could say player 1 dot print health. Something like that. Then we need a function up here to print the health because we want to have a very unique string for that. So we would have something like def print health. And we could say something like print f string your character, your, let's do this, your, and then self dot character as a player health of, and then we plug in that, should be self dot health. Okay. And so now if we call that before and we call that after we lower our health, we should have two different values. Okay, so now my player health is 100, and then our org has a player health of 92, right? And then we can see we have our inventory added up in there. The thing is we don't have to store a health for every single player. We just create the one player object. It has all those attributes associated with it. Everybody kind of see how object-oriented programming works? The book does a good example, or that page does a good example of explaining it with dogs. You could have sub-objects from within player objects. So you could start with a player object that has these attributes, and then maybe we get more detailed that this is a child player. And so a child player has different attributes than maybe a adult player. But because they're both players, then they have all the attributes from player. So it inherits things from its parent, and then it figures out how to use things below. So that's a little more advanced than I need to cover in this beginner class. But for this point, this is what I want you guys to be doing if you need to write your own OOP from scratch. So you have two options for the final. You can either write your own OOP from scratch, or you're using a third-party module. So for example, Caden's using the InMap module, right? Well, that means he has to go out, install the InMap module, and then he has to read all the documentation on how to use InMap. Well, that is basically a class called InMap, and then it has every sub function below that, and then he has to call that in order to execute that code. So where you're using PyFiglet, same concept. All right. So if you're using a third-party module, in other words, I have to pip install it. So if it's something that's already built into Python, like os.system or system.exit, that doesn't count, right? It's something that I have to pip install, which means you had to go out and figure out how to use that actual module. So just like when Caden was working with InMap, he had to go through the documentation, determine how to read that, determine how to use it. That's fine, because now you know how to read documentation. Or you could be writing your own stuff from scratch. Either one's acceptable for your final, but you have to have something there. And a lot of times you guys already built some of this stuff out. Now you just need to containerize it into an object so that it all makes sense. Anybody have any questions on OOP? Whatever makes sense for your project. Most of you will probably just have a player object and go from there. Right? If you guys are moving between files or something like that, you may have to pass that player object off to the other file. Does that make sense? So if you're wanting to update or change something in this, and say I got another file that's over there, my functions file, right? And the way I imported that, then I would have to pass it over to that function. So it needs to accept that to get access to the player one object. That's rare, but it depends on how you chopped up your code in order to get the login requirement. Okay. It shouldn't matter, because most of those functions are probably just pertinent to whatever object you had, and therefore you're going to put those functions inside of here. So for example, in your text adventure game, they're going through at different levels to go different places, right? That code should stay in another one. But anytime you're updating a player object, well, then we need to pass that player object around so that we can modify its inventory somewhere in the game. All right. So I will go ahead. Let's see here. Question off topic. Can this be answered at the end of class? I hate to ask this. Yeah, if you missed that in the beginning, Bailey, I'm going to address that now. So let me stop this recording.